by Menu Barrier, and today we are going to discuss the topic Big Data. Big data refers to a large set of data, and there is no minimum amount of data needed for it to be categorized as big data. Big data is available in an endless number of places, and it only increases as time goes on. A simple Google search will enable you to find a data repository for just about anything. Many people are not aware of just how much data is already available for access and analysis. Now let us get into the topic. What is big data? Big data basically refers to a huge volume of data that cannot be stored and processed using the traditional approach within the given time frame. How huge this data needs to be in order to be classified as big data? There's a lot of misconceptions while referring to the term big data. We usually use the term big data to refer to the data that is either in gigabytes or terabytes, petabytes or exabytes or anything that is larger than the size. This does not define the term big data completely. Even a small amount of data can be referred to as big data depending on the context that's used. For example, first example we'll take an email system. If we try to attach a document that is of 100 megabyte size to the email, we will not be able to do so because the email size will not support an attachment of this size. Therefore, 100 megabyte of data with respect to email can be referred to as big data. Or another example, we have around 10 terabytes of image files for which certain processing needs to be done. For instance, we may want to resize and enhance these images within a given time frame. Suppose if we make use of the traditional systems to perform this task, we will not be able to accomplish this task within the given time frame, as computing resources of this traditional system will not be sufficient to accomplish this task on time. Therefore, this 10 terabytes of image files can be referred to as big data. Now, big data is classified into three: structured, semi-structured, and unstructured data. The data that does not have a proper format associated to it can be referred to as structured data. An example can be spreadsheet, Excel spreadsheets, CSV files, etc. The next one is semi-structured data. It does not have a proper format associated and can be referred to as semi-structured data. For example, the data that is present within the email, log files, and Word documents, etc. Unstructured data. The data that does not have any format associated with it can be referred to as unstructured data. For example, image files, audio files, video files, etc. Now, characteristics of big data. Big data can be categorized into three important characteristics. The first one being volume. This refers to the amount of data that is getting generated. The next one is velocity. It refers to the speed at which the data is getting generated. The last one is variety. Variety refers to the different type of data that is getting generated. These are the three important characteristics of big data. Now, big data is increasing day by day and it faces a lot of challenges. The two main challenges associated with big data is discussed here. The first challenge is how do we store and manage such huge volume of data efficiently? And the second one is how do we process and extract valuable information from this huge volume of data within the given time frame. These two main challenges are associated with big data that leads to the development of Hadoop framework. How is big data stored and processed? In a traditional approach, usually the data that is being generated out of the organization's financial institutions, such as banks or stock markets and hospitals, is given as an input to the ETL system. An ETL system would then extract this data and transform this data that is, it would convert this data into proper format and finally load this data onto the database. Now, end users can generate reports and perform analytics by querying this data. But as the data grows, it becomes a very challenging task to manage and process this data using the traditional approach. This is one of the fundamental drawbacks of using traditional approach. Let us understand some major drawbacks of using traditional approach. The first drawback is this expensive system and requires a lot of investment for implementing or upgrading the system. Therefore, it is out of the reach of small and mid-sized companies. The second drawback is scalability. As the data grows, expanding the system is a challenging task. The third drawback is it is time consuming and takes a lot of time to process and extract valuable information from the data. Now, what is Hadoop? Hadoop is an open source framework developed by Doug Cutting in 2006 and it is managed by Apache Software Foundation. The project was named Hadoop after the name of a yellow stuffed toy elephant which the Doug Cutting's son had. Hadoop is designed to store and process a huge volume of data efficiently. The Hadoop framework comprises of two main components. The first component is HDFS, which stands for Hadoop Distributed File System, and second one is MapReduce. The HDFS takes care of storing and managing the data within the Hadoop cluster, whereas the MapReduce takes care of processing and computing the data that is present within the HDFS. How Hadoop works. The Hadoop framework comprises of the Hadoop Distributed File System and MapReduce file framework. How the data is managed and processed by Hadoop framework. The Hadoop framework divides the data into smaller chunks and stores each part of the data on a separate node within the cluster. We have around 4 terabytes of data and a 4-node Hadoop cluster. The HDFS will divide the data into 4 parts of 1 terabyte each. By doing this, the time taken to store this data onto the disk is significantly reduced. The total time taken to store the entire data onto the disk is equal to storing one part of the data, as it will store all parts of the data simultaneously on different machines. In order to provide high availability, what Hadoop does is, it would replicate each part of the data into other machines that are present within the cluster. The number of copies it will replicate depends on the replication pattern. How HDFS works. The HDFS supports the rapid transfer of data between compute nodes. As its outset, it was closely coupled with MapReduce, a programmatic framework for data processing. HDFS uses the master-slave architecture. Thank you.